So many of the companies, those who are working on embedded system, they are working on software development, hardware development, and product development. The products like our daily necessities. If you go for automobile thing, take Mahindra, Volvo, okay, or L&T, they are developing the dashboards for automobile equipments. And if you go for Airbus or Boeing, so these are the famous companies. They are developing the dashboards for flights, jet planes, or helicopters. If you go for NIT and KPIT, they are in the research and development. If you go for TCS, Wipro, Tata Elxsi, Infosys, Zensar, these are the companies. They are developing the IT part, that is software development. They are developing the embedded firmwares, drivers, and all these things. This is how the industrial potential is. So if you want to get the job in embedded systems, we have to apply as an intern or a fresher job in the following companies with the following skill sets. If we are going for applying for embedded system job, we need to have a skill about microprocessor, microcontroller, assembly programming language, C programming language, and electronic basic component subjects like circuit analysis, okay, digital electronics, and some part of the signals communications. If you are going to the combined 5G technology, 4G technologies, you need to have embedded knowledge and signals and systems and digital signal processing, analog signal processing knowledge also. There are various applications in all the embedded domains. See, if you are going for networking side, okay, so that is based on communications. So if you want to design an Ethernet, you need to write a Ethernet code. Ethernet is nothing but internet. RJ45 what we connected to our laptops or desktops. So we need to write device drivers. This Ethernet has to interface with our microprocessor and microcontroller. So we need to know what is communication between these two devices. What is the interface? And next thing is, if you are working on 5G technology or 4G technologies, how these baseband signals are working. If you want to design an antenna, so how we want to design this antenna? So how we want to send the signals on this antenna? And how this antenna chip has to communicate with the microprocessor or microcontroller. So we have GPS module, we have GSM modules. So these interfaces, how we want to write all those things. And we have particular applications like real-time operating systems. This is also part of embedded systems. So if you see the example of a car dashboard, the car dashboard is a real-time operating system. So this works with RTOS and your wheel alignment, your steering position, your engine health, your seat capacity, your pressure weight on the tires, and indicators, LEDs, bulbs, airbags control, fuel control, engine heating control, oil control, coolant control. Everything is monitored based on dashboard using real-time operating systems installed on embedded system board. So like this, we have different types of career opportunities in the industry: embedded software engineer, embedded hardware engineer, embedded application engineer, and even embedded marketing and sales also. So you have got an opportunity to complete embedded systems, okay, and BTech you have done with ECE, and you completed a Masters of Business Administration, MBA. Then you can enter into marketing and sales. You have the subject knowledge of embedded systems, and you can explain the specifications. Okay, so how Qualcomm will approach Samsung to sell their processor. Okay, Samsung is a good manufacturer of its own processor, but we want to buy Samsung phone with Qualcomm processor, Snapdragon. So what we will be doing? Qualcomm sales manager or marketing team, they will go and give a presentation to the Samsung staff, Samsung application engineers. Okay, so that this is Qualcomm Snapdragon processor, which will perform better among all the chips in the market comparatively. Even though the price is high, the performance is premium. This is what they comment, Qualcomm. So that's why their marketing and sales are very high on the Qualcomm Snapdragon processor. Coming to the application engineer. So application engineer is nothing but who develops the application software. So I have an application software. Okay. So I have a dashboard. Dashboard is nothing but .NET application kind of thing. So where I have to drag and drop each and every icon and get it programmed. And embedded hardware engineer. Hardware engineer who is connecting the interfaces, who is picking up the right components and all those things. Embedded software engineer. Embedded software engineer, he is the premium engineer in embedded systems who has knowledge on kernels, Linux operating system, real-time operating systems, and device drivers, and testing about the code what he has written in the programming language. This is the mere career opportunities. The candidates or the participants who want to build their career in embedded systems. Hope everyone is following and understood, right? Yes. Next, what do you have to learn? So if you want to become an embedded systems, you want to be proficient in C programming, C++, and embedded C. See, whatever you do, daily practice, minimum 1 hour to 2 hours C programming language. Even these days, I try to implement C programming languages in shell scripting. Some of the constructs like functions, okay, or else using operators, all these things. So coming to data structures. So as we have learned on the high level part of embedded systems drivers code in development, we require data structures. And to debug the programming language, we need to learn C debugging skills also. Okay. Next thing is kernel programming. Kernel programming is nothing but we have Linux. In that Linux, we write kernel. Okay. Shell and kernel. So to build a kernel, we need to write a programming language. That is what called as kernel program. Next is device drivers. So device drivers we write in assembly, system C, C language. And next is real-time operating systems. So real-time operating systems we have seen Vertex, VxWorks, real-time OS, and all those things. These are the basic skills required for software programming language. Next is hardware skills. Hearing that. So for an hardware engineer in embedded systems, he has to have a knowledge about basic electrical, okay, electronic concepts, microprocessor, microcontroller architectures, microcontroller programming environments like IDE or Arduino IDE, TIL IDE. Okay, the tools of applications, microcontroller programming environment applications. Next is protocols and interfaces. He should have the knowledge about sensors, actuators, and peripheral hardwares. Next is electronic circuit board design and troubleshooting. That is PCB design. Hardware skills for an embedded hardware engineer. That is that. You are able to get it? Okay, sorry. Next is product life cycle. So product life cycle in embedded systems. Okay, we have a design. For the design, we have specifications and constraints. We have built up a block level diagram and data flow graph. And we started for the development of software, hardware, and building. Okay, we have completed hardware and software. Then we are going for testing. So once the testing is done, we'll go for deployment for the testing for the production. If there are any new constraints or new requirements, analyze the problem. We need to check for the new requirements and new constraints. And if there are new constraints and new requirements, we need to analyze how should be embedded, how should we incorporate this new logic or new constraints to the existing design. Next is what microcontroller, microprocessor we have learned in our academics. That is the basic microcontroller is 8051 and microprocessor is 8086. And apart from this, on the high level, we have learned Arduino IDE, Arduino microcontroller. Arduino microcontroller board is also having Atmega 3 to 8 microcontrollers. And apart from this, we have Atmega 8 microcontroller. And next is Raspberry Pi. Raspberry Pi is the high level board. Okay. And ARM boards are also high level boards and Intel boards are also high level boards. ARM microprocessor or ARM microcontroller, they are of advanced RISC machines. Those are 64 and 32-bit microprocessor or microcontroller boards. For example, if we consider Raspberry Pi is ARM A9 series, that is application series 9 is the version. And if we consider our recent mobile phones, okay, those are ARM 11 application series. And there are different boards from Intel. They are Intel Galileo boards. You can check in the internet. Okay. Sir, how to write a grand test and assignment? Please send the link, sir. So, Venkata Sirisha. So, Blackbucks team will help you with these questions. Okay. So, this is our completely subject related topics. If you have any questions related to subject, please post on the chat window. Okay. So, introduction to Arduino. So, what is Arduino? Types of Arduino, Arduino Uno board, Arduino board hardware. So, Arduino is an open source software platform used for building electronic projects. So, in our traditional days, if you want to learn 8051 microcontroller, we have a breadboard. We want to put that 8051 microcontroller on the breadboard. Okay, on the either sides, we have to connect the pins. And using a voltage source, we need to connect to 5 volts accurately. And using signal generator or function generator, we generate some waveform and supply to the pulse signal. Okay, and we estimate the output by writing the assembly language code. This is how we have done traditional. And nowadays, all these are components. All these are built on a single microcontroller board. That is open source Arduino. And using that Arduino, we have built some example boards, projects, that also. So, Jyoti Reddy, this is out of scope of my answer. Blackbucks team will answer this question. Please post these questions to Blackbucks. Okay. Arduino consists of two components: a physical programmable circuit board design, okay, which consists of Atmega 3 to 8 microcontroller, and a integrated development environment, that is IDE. We write the code, we upload, we compile, we check the result. Okay, this is what Arduino is. Types of Arduino boards. We have different types of Arduino boards like Arduino Uno, Arduino Mega, Arduino Lilypad, Arduino Micro, Arduino Nano, Arduino Mini. So all these are coming from the Arduino family, but they have different types of peripherals and different types of communication protocols. And among them, the highest specified boards are Arduino Mega, Arduino Micro, and Arduino Mini. Okay. So compared to the popular Arduino boards, so first one is Arduino Uno, which is at Mega 328 microcontroller, which has a clock frequency of 16 megahertz. And Arduino Nano, which is also working on at Mega 168 or at Mega 328 P microcontroller board, which is also having 16 megahertz frequency. So at Mega Arduino Uno, we will use it for prototyping and desktop projects. And if you go for Arduino Nano, we will build some small profiles, simple projects of real-time use. Arduino DOA, which uses ATSM 3x80E board, which has a frequency of 84 megahertz. So Arduino DOA is the high performance prototyping with superior analog IOs. Next is Arduino Mega. Arduino Mega is having a microcontroller of Atmega 2568, which is having 16 megahertz frequency. High performance IOs, more space in the RAM and memory. Clear so far, everyone? This is all we have learned in the initial classes. This is just recap for all the students, those who have to brush up their skills. Next is brief description about Arduino Uno board. Arduino Uno board, okay, which has. So here I can explain you in detail. Few minutes. So this is DC power supply and this is USB power supply. Both the power supplies can be used. And if you want to use external power supply, you need to use AC adapter to DC adapter, AC to DC adapter, which operates on 7 to 12 volts. And you can use USB 5 volts power, and it is having multi-purpose programming serial port. And above the USB, you have a reset pin. Okay. And next, this is your Atmega 328 microcontroller. Atmega 328 microcontroller is a 8-bit microcontroller which operates at a 16 megahertz frequency, 32 kilobytes of flash memory, 1 kilobyte of EPROM, or 2 kilobytes of SRAM. So this is the capacity of data memory and code memory and flash memory with a frequency of 16 megahertz clock. These are the basic specifications of Atmega 328 microcontroller. And using the pin diagram of Atmega 328 microcontroller, this board is built to have 2 serial communication ports and 6 pulse width modulation ports, PWM. And next, onboard LED with receive and transmit LEDs also. And 13th pin is connected to the output pin, and it is having pin LED also output. Okay. And next, in the bottom side, we have 6-channel analog input and output. We have ADC, analog to digital converter. And apart from the power adapter, we have 9 volts battery source also, or 5 volts battery source also. So here we have power pins. So if you want to do a remote application, you can connect the battery using 5 volts or 9 volts. Okay. So this is the USB port, and the below one is the power adapter. And this is Atmega 328 microcontroller, And these are the analog 6-channel analog pins A0 to A5. And these are the digital pins. In these digital pins, we have serial pins, pulse width modulation pins, reset pin, crystal oscillator. Crystal oscillator is used to generate external frequency to the microcontroller. Next, we have two TX and RX LEDs, where these are used to communicate USB serial dump code. And next, below RX and TX pins are the serial communication pins. Protocols and interfaces with Arduino Uno board. So, how we will interface the different applications or different devices using Arduino board. So far, everyone clear, right? This is on the fast track and fast pace. If you have any questions, please stop me on the slide and ask me the question. Hope everyone is clear with this. Rekha, Aditya. Yeah, Nagatriveni, thank you. So to interface Arduino IDE, Arduino board with LED, so we will use Arduino board, breadboard, resistors, LED and few jumper wires. So in this way, we will be connecting LED, the positive terminal to the output pin of the Arduino board and negative terminal to the ground. So why we are using resistor? So resistor is used to control the flow of current. So resistor is always a principle called current limiter. So current will damage our devices, not the voltage. So this is a simple program to blink LED. So void setup. In the setup, I am declaring pin mode 13th pin. So I have connected 13th pin. If you see the pin diagram here, 13th pin, I am connecting it to the positive terminal of my LED. So pin mode 13th pin as the output, and void loop, I am blinking this LED for every 3000 milliseconds on and off. Got it, everyone? Any question in the programming and interface with the LED Arduino? Blackbucks, please take care of these people. They are not concentrating on the class. They are asking irrelevant questions. So, in the last 15 minutes, I'll request, Blackbucks team to help you with all these questions. From 9 to 9:15, we will discuss with the Blackbucks team about these questions. Clear? Everyone, I don't find any irrelevant question apart from subject, embedded systems, program, interfaces. If I see any irrelevant answer or relevant question, Yes, Aditya. So this is just rewinding our subject. Yeah, this is very important. Just to brief out your subject before going to the exam. So that's why. So do not put any relevant questions in the chat box that will interrupt me or distract me. So if you have any question related to subject, I'll pick it up and I'll answer. We have another set of programming. Operation of LED using switch. So when we press the switch, LED has to blink, and when we release the button, LED has to turn off. So for this, we have to interface Arduino board with LED and switch. So I am connecting my switch to second pin, and the other set of connection is connected to LED. And I am passing 5 volts to my switch. Once the switch is on, LED will blink. Okay, this 5 volts is passed from the microcontroller to the pin 13. So here, when I connect this microcontroller board to my laptop and download the code, okay, so here I have 5 volts. So here I have connected my switch. Okay, so when I press the switch, this 5 volts will be sent to the pin 2 of microcontroller board. This pin 2 will communicate internally with the pin 13 to blink the LED. That's how we have written the code. Let's understand it from the code. So switch is pin 2 and LED output is 13. That is output. So pin mode, switch as input and pin mode LED as output. Pin 2 is input and pin 13 is output. So while loop, when I am pressing the switch, LED has to turn off, and when I am releasing the switch, it has to turn on. So this is active low switch. So digital read is nothing but it is reading the input from switch. So when I am pressing the switch, the switch is giving what it is giving. It is sending the data in the form of voltage. If the voltage is 0, it will turn off the LED. And when the switch is released, it is high, then it is blinking the LED. Next is, we have learned this thing concept, interfacing motors with Arduino board using L293D motor controller driver IC. This motor controller driver IC has 16 pin. Okay, among the 16 pin, we have 2 VCC, 4 ground, and 2 enable pins. We have how many inputs? 4 inputs and 4 outputs. So at a time, we can connect 4 motors to this L293D IC. On one direction, we can control 2 motors, and another direction, we can control another 2 motors using enable 1 and 2 and enable 3 and 4. Got it, everyone? So we cannot directly interface motor with Arduino Uno board. If we do that, the voltage supplied to the motor driver is not sufficient by the Arduino. And how to move that motor in clockwise direction or anti-clockwise direction, and what will be the speed of the motor, that all can be controlled using L293D IC. Okay, that is a motor driver IC. Clear so far, everyone? Yeah, thank you, Aditya, Sunil. Adepalligudem. Adepalligudem, what is D? Next is how we are controlling the speed of a motor, DC motor. So we are controlling the speed of a DC motor using pulse width modulation. So as we know from the diagram, the pulse width modulation based on the duty cycle. So the duty cycle is 0%, and here the duty cycle is 25%. So among the on time, this much is the on time 25%. So the motor will run only 25%. And what is the delay here? Suppose it is 1 millisecond. And here it is 2 milliseconds. And here it is 3 milliseconds. So based on the duty cycle, the motor speed will be controlled. Okay. This is how the pulse width modulation will work to control the speed of a DC motor. Direction control. So if you want to move the motors in forward direction, we have to give 1 0 0 1, sorry. If you want to go in the backward direction, we have to give 1 0. In 1 and in 2 are the input pins. Got it? If both are high and if both are low, their motors are turned off. This is how we are converting L293D as a motor driver controller IC. So this is the interface. So pin mode, motor, motor 1, motor 2, motor 3, motor 4. So all these motors are output. So based on the motor control, where I am supplying 3 to 12 volts power supply output using battery source or any other source. Next is LCD. So LCD is another peripheral or hardware where it is a output device. We display value on the text on the LCD screen. This is called 16x2 LCD. So each line has 16 characters and it has 2 lines. Okay, the first pin diagram is VCC, VSS ground. VSS is the ground and VDD is the supply 5 volts and V0 is the contrast and RS is the register. So 5 is read write. So read write is nothing but always we write data to the LCD. We cannot read any data from the LCD. So enable pin. Next is D0 to D7. We can transmit the data using microcontroller to the LCD in 2 formats. One is 8-bit format and another bit is 4-bit format. If you are transferring the 4-bit format, we have to send it 2 times. If you are transferring 8 bits, we have to send it 1 time. And 15 pin and 16 pin are used to backlights of the LCD. So here the potentiometer is used to control the brightness of your LCD, contrast of your LCD. So this is our LCD programming. So I am connecting all this to the microcontroller. So I am declaring the 4-bit data mode D4 to D7. Okay. And I am printing on the 2 lines internship classes embedded systems. I am setting the cursor position to 0 0. So it will print first line internship class and the second line embedded systems. Clear? Any questions? Participants? Is this clear? LCD peripheral. Tadepalligudem. This is not a complete descriptive class to explain you on the theoretical, practical. Already we have covered this syllabus. Tadepalligudem. What is your name? Nani, what didn't you understand? Which part of the explanation didn't you understand about LCD? What is the meaning of replay? No. Nani, you can ask your doubts or your questions, anything which is related to the assignments to the Blackbucks team. I have requested already. This is fast-paced class. There is no more doubts related to the assignments. Initially, when I am explaining, it was very much clear. Okay, it was time taking. And this is on the fast pace. Okay, so we have to complete the course as soon as possible. Okay, if you need any help, Tadepalli Gudem or Nani, you can take help from Blackbucks team. They will address your questions all the time. Okay. So far, what I am teaching in the class current slides, what is your question on the LCD part? Whether you understood or not. Next is, we are interfacing GSM module or GPS module. So GPS module, we have 4 connections that are ground, VCC, TX pin and RX pin. So the crystal part is, this is antenna and we are using a short antenna. And this is your GPS chip. And this is your serial communication connection chip. These are the serial connection pins, TX and RX. Using this serial connection, we are connecting this GPS module to our Arduino at Mega 328 microcontroller. So using these connections, we will get numbers, latitude and longitude values as the output. So this is the interface diagram. Okay. So VCC ground, black and red, and yellow and green are connected to the TX and RX pin of microcontroller board. So this is how the code starts. Input TX, int TX, int RX. Those are integer values. Next is software serial, GPS. Okay, it has to receive the software serial. We are printing on the serial monitor of the Arduino IDE for latitude and longitude values. It is pinning, it is pointing to the serial GPS, RX and TX pins. So at a rate of 9600 baud rate, I'm receiving the values from the GPS module on my Arduino board. Here, next is ADC. ADC is nothing but analog to digital converter. So all the microcontrollers are digital devices. Those are developed on bits and bytes. So if you want to interface any sensor or actuator, example, temperature sensor, gas sensor, pressure sensor, fingerprint module, or RFID module, whatever the module is, we have to interface using ADC. If microcontroller doesn't understand digital or analog data, we have to use ADC, analog to digital conversion. So for that, we have 6-channel ADC on our Arduino. As an example, we are covering DHT sensor. DHT is nothing but digital humidity and temperature sensor. So this sensor is having serial data, VCC and ground. We are connecting DHT sensor in this way. So we are reading the sensor value. temperature and humidity on the serial monitor. We have defined DHT as the input to the microcontroller at pin 7. Yeah. And we are calculating the temperature and humidity values. Clear? And all the data we are printing is raw format. So next is MQ7. This is a gas sensor. So using this gas sensor, we are detecting gas. Okay. The gas concentration is up to 110 to 10,000 ppm. Pulse positions per module. That is a unit for gas state. So MQ7 I am interfacing it to A0 pin of my Arduino Uno board. So sensor is the input device. So it will be connected to the sensor input pin. That is A0 analog read. So it will read the value and display on the serial board. So another advanced board we have learned in the embedded systems and IoT, that is NodeMCU ESP8266. What is NodeMCU? NodeMCU is also an open source development environment built around the ESP8266 Wi-Fi module. So NodeMCU is the different board and ESP8266 is a different board. ESP8266 is the Wi-Fi chip, this part. And NodeMCU is this part. Okay. So connecting this NodeMCU using this Wi-Fi, it has become ESP8266 NodeMCU Wi-Fi module. This is also an open source development board. Like this, we have plenty n number of boards in the market where we can learn, we can integrate other peripherals, and we can develop products as many as we can. And if you are interested in the startup, you can go for a startup company. You can build your own company for developing such products using these boards. So power is 3.3 volts and the DC current is 250 milliamps. Memory is of RAM 160 kilobytes, DRAM is 96 kilobytes, flash is 4 megabytes. So these are the board specifications. Features of NodeMCU similar like Arduino. Main component is ESP8266 Wi-Fi module. Using USB, we can supply the power and we can upload the code and low cost. Okay. So someone who is aware about the cost of NodeMCU can put the chat window. So did anyone purchase these boards to practice at your home? Please someone ping me how you are experiencing. Did you students purchase NodeMCU Arduino board at your home to do some assignments or practice at your home? Did you purchase these boards? Someone please comment if yes, yes, if no, no. You should be dare enough to answer no also. Okay. Yeah. And there is no explanation required from your side if it is no answer. Why? Because if you are learning, if you are practicing, you are the person who is going to win the board. And if you are not buying, if you are not practicing, you are the person who is going to lose. See, as a trainer, I can train you maximum what are the inputs I can provide or shortcuts I can provide to you. But one who is the person you have to make your hands dirty to learn the subject. When I was a childhood, I used to observe in my village, okay, a old lady who is around 60 plus, she used to make baskets using bamboo. Okay. And she used to have a granddaughter who was playing with that bamboo sticks. And those bamboo sticks, they are peeled and they are stretched and they are cut down to make baskets and everything. And that is the art of making from her experience. Her age is 60 years old, approximately. But whereas the child observing those skills and started binding those sticks to form a hand fan. You know what is a hand fan? Visnakarra in Telugu. So the skill what we want to learn can be learned by observing or by seeing the techniques how they are constructing or building the things. So these whatever the classwork I am giving, whatever the course I am teaching to you people, this is just a context. This is just a opening page of your career in embedded systems. So unless until you make your hands very dirty, burn these boards, experiment a lot, then you can become a real device driver engineer or a Linux engineer or a hardware engineer or an embedded engineer, application engineer or a programmer. Really, I'm telling. In my bachelor's, I used to have minimum 4 to 5 boards. And at that time only, in 2010-11, I have got ARM LPC 1768 board, 2148 board. Okay. So I used to save my pocket money. You can just see. M3 is nothing but microcontroller development board. Okay. So at that time, we used to have around 2000, 2500 like this. So this board still I am having in my practice. So these kind of boards I used to work for my lab. This is very high level board. And this is having microcontroller 3 series. So if you are interested very much, you can go for application series also. So these are some of the application development tools. All these are from ARM microcontrollers, but they have designed by some other companies. So you can see they are using ARM processor. So using here, we used to have a small, here the number 1 you can see. So here we used to put SD card. Okay. So here we used to connect a micro jumper board. Okay. For serial communications like SPI, I2C, UART, pulse width modulation and everything. So these are all the peripherals. So these kind of high level boards, I target you to reach. Okay. So better try to habituate. Okay. Instead of spending the money, you spend your money on education. Okay. Next is NodeMCU. NodeMCU pin diagram. So NodeMCU has multi-purpose or multifunctional input pins and output pins. Okay. So each and every pin has different functionalities. Some pins has single function, some pins has 2 functions, some pins has 3 functions. If we see right side, there are some pins which are having 3 functions also. So whatever the pins which are in white color, those are general purpose GPIO pins. And the pins which are in green color, okay, those are serial communication pins. Here, these pins, those are for SPI and I2C. And those pins which are in light blue color, they are for UART. And here the flash pin, we are using this flash pin to run this microcontroller in a bootloader mode. Bootloader mode means when we want to run our laptop in the bootloader mode, we'll press F9 or F10 keys. So similarly, we'll use flash mode. And next thing is user mode or wake up mode. So when the board is in sleep or it is not able to receive data, so using wake on internet or wake on LAN, using this pin, we can use wake up. And if the board is on the privileged user, so we want to make it on the user mode, then we'll use user program. And apart from this, we have only one ADC pin. If we want to use multiple sensors connecting on ESP8266, we need to have an external ADC. Those external ADC we can connect to this GPIO pins to receive digital data. And these orange pins are also connected to serial communication, which are A2C SPI. So for programming ESP8266 NodeMCU, you can use Lua based programming or Arduino IDE. So this is ESP8266 Wi-Fi chipboard. So the key features are 32-bit processing and 16-bit instructions. And this is having Harvard architecture. Separate instruction memory and data memory. If you have same memory for instructions and data, then it is called one-human architecture. Based on the compute instruction set, we have 2 kinds of architectures. One is CISC architecture and one is RISC architecture. CISC architecture is complex instruction set computing, and the other one is RISC architecture, reduced instruction set computing. So whatever the programming language we are using, those all are reduced instruction set computing. So the computers or the CPUs which work on the old IBM processor, those are all of CISC architecture. Okay. So based on the memory, we have categorized two architectures, that is Harvard architectures and von Neumann architecture. If we take the example of Harvard architecture, which has separate memory for code and instructions. Data memory and instruction memory are separate. If we have data memory and instruction memory same, then it is called as von Neumann architecture. Clear so far, everyone? You are able to catch? Thank you, Vinay. Triveni, thank you. See, this is a block diagram. So the left blue color part is the analog part, and the orange color part or yellow color part is the digital part. Great, thank you. So the yellow color part is completely related to the ESP8266 NodeMCU. Okay, and blue color part is ESP8266 Wi-Fi. So Wi-Fi has radio frequency band, switch, transmitter, analog receive, data, and phase lock loop for frequency, and crystal oscillator for generating the crystal frequency, power management unit, and biasing circuit. So all this data is converted to a digital baseband. So the digital baseband is read from the data of ESP8266 and send it to the microcontroller. So microcontroller has accelerator, sequencer, CPU, registers, MAC address, and other things. And apart from that, we have serial communication interfaces like standard input and output, and SPI, serial peripheral interface, and GPIO, and I2C, and power management unit and SRAM. This is the block diagram of ESP8266 NodeMCU. So ESP8266 pin out. Only ESP8266 Wi-Fi. So this has one ADC. Green colors are GPIO pins, and other blue colors are UART or serial communication. And the below green color pins are SPI and I2C serial communication. So in comparison with NodeMCU ESP8266 Arduino uses Atmega 328 microcontroller. ESP NodeMCU uses ESP12 module. So comparison features: Wi-Fi. Yes, NodeMCU has Wi-Fi. Arduino doesn't have Wi-Fi. Cost is generally cheaper. Various can be more or expensive. Like Arduino, Arduino DOE, Arduino Mega. These boards are little bit costly. Clock speed 80 megahertz and Arduino is 16 megahertz. Memory 160 kilobytes and 2 kilobytes on Arduino. Programming Arduino IDE, Lua, MicroPython. But whereas Arduino, we can use only Arduino IDE. And 10 GPIO pins and 14 digital IO pins on Arduino board and 6 analog pins. And we have only one analog pin on NodeMCU. Operating voltage 3.3 volts, very low voltage. Okay, less power consumption on NodeMCU. And Arduino is 5 volts. Power consumption is higher on the NodeMCU. Whatever the peripherals we interface, those will take most of the power from the NodeMCU board. And the power consumption on Arduino board is lower. Why? Because we have supply of 5 volts. So this 5 volts is sufficient for all the peripherals to interface, like sensors, LEDs, and other actuators. Interface is micro USB and USB Type B interface. And the memory is 4 megabytes and 32 kilobytes. What kind of memory it is? Flash. So easy to use. About the complexity, both are easy to use, I can say. Okay. Community support is growing on NodeMCU, and on Arduino it is very high. Okay. So we can build IoT projects based on NodeMCU whereas it doesn't have Wi-Fi module, so we cannot build IoT projects or IoT prototypes on Arduino. If we connect external ESP8266 chip to Arduino, we can make it as IoT. Clear? So far, Balaji, Prem, Triveni, Aditya. Comparison. Yes, sir, Sanjay. Applications of NodeMCU. So NodeMCU, we can apply it for IoT projects, home automation systems, sensor networking, prototyping, and development. So in IoT projects, we want to build a smart pollution control board. So we'll interface smoke sensor, carbon dioxide sensor, oxygen sensor, hydrogen sensor, nitrogen sensor. Okay, this is IoT project. Home automation. I want to control lights in the master bedroom, fan in the master bedroom, and exhaust fan in the washroom, and balcony lights and everything using home automation. Sensor networking. So connecting multiple ESP8266 in a mesh is called sensors networking. So sensors cannot be directly networked unless until they have processing element. So if that is a bare sensor, okay, that doesn't have any processing element. If we take any sensor that is having processing element, we can make it a sensor network. Else we need to use NodeMCU boards to connect to sensors and make them into a network using Wi-Fi mesh. Next is prototyping and development. So whatever the IoT projects we develop, we can make them as a prototype and make them as a we can build them to a product level also. Clear? Thank you. So IoT application development, sensors integration, data transmission. So for building smart cities, smart homes, industrial applications, smart gadgets, and smart cars. So we will use IoT applications development. So for using the IoT open source application, we are using Blinky app. So Blinky app is also an open source Android iOS application and web application too. So to install Blinky app on the mobile phone, go to the Play Store or iOS store, and install the Blinky app and go for sign up and create a project template. And using the project template, you want to control the LED blinking or you want to receive the sensor value, whatever it is, you need to do that. And connect the sensor using channel code or Blinky template code on the internet using your project template on the ESP8266. So how we will connect Arduino IDE on the ESP8266? So once you connect the USB micro USB to the ESP8266, you need to go to the preferences. On the preferences, you need to select the board. Okay. To select that board, you need to add this URL packages to download ESP8266 and connect the board to the ESP8266 to install the drives. Once the drivers are installed and COM port is connected, you can check out ESP12 E module on the board. Once it is connected, select an example code, blink LED or button or sensor, anything, upload the code and check the results. So this much is clear. Software part of IoT and hardware part of IoT. And next is interfacing part of IoT with ESP8266 NodeMCU. Please give me 2 minutes of time. I'll fetch a cup of water and come back to you. Okay. So far is clear, right? Everyone, are you able to follow? This is just a follow-up class. And the pace is very fast, right? Thank you, participants, for the break. So we'll continue, right? KDK, I was on a break for 2 minutes. Sorry. So are you able to hear me, KDK? Yes, sir. So far we have covered about ESP8266 software part and hardware part and Blinky application used for IoT integration for ESP8266 NodeMCU. Now we are interfacing LM35 with NodeMCU. LM35 is the basic temperature sensor which has a threshold of plus 50 to minus 50 degrees Celsius. So this is a three terminal device which has VCC and ground and analog pin as the output. So now we are interfacing this NodeMCU with ESP8266. We are connecting the VCC to the 5 volts and ground to the ground pin and V out to the analog pin of the ESP NodeMCU 8266. So once this is connected, we are connecting the data on the Wi-Fi of using Blinky app. So we are creating a template or a project using NodeMCU LM35 temperature sensor. Okay. So now we are adding the LM35 temperature sensor to monitor the data. So once we have this LM35 interface, so we are reading the data on the virtual pin to display the data on the Blinky app using some widgets, charts, graphs, and everything. So at last, we will be seeing the values here. So minimum value, maximum value, degree Celsius, and whether we get in the graph format or pie chart model. Next is this is a code we have to upload to the NodeMCU. So this is uptime of the sensor. So we are getting a continuous temperature sensor value. So it is varying. Okay. So it is continuously monitoring the data. And here is the graph of 12 hours. So this is a current temperature value and this is a graph for the 12 hours value. And even we can continue it for 1 day or power up how many days. Clear so far? Everyone? Is this clear? So this is an example for ESP8266 NodeMCU interface LM35 analog pin. KDK, Triveni, Nani, Sanjay. Yeah. Next is how we can measure the Wi-Fi signal strength using ThinkSpeak. So ThinkSpeak is another application for IoT, okay, where this is used to see the data in the web application. So install necessary libraries in the Arduino IDE. Once we install this, we can connect the NodeMCU and we can check the ThinkSpeak. So ThinkSpeak, we have to create a channel and we'll get some API code. That API code we have to install in our code. API code is a key authentication code to the application, web application, to our software code. So once we connect this and enter the Wi-Fi username, SSD and password, then it gets connected. So using this, we are checking the signal strength of our data or ESP8266. Next is post temperature data and read from the channel. So we are posting the temperature data on the ThinkSpeak and reading the data from the temperature channel. So next is real-time operating system. So real-time operating system is an embedded operating system where this operating system performs only one kind of application or one kind of operating system processes. It is not like general purpose operating systems like Windows or Linux, Red Hat, Ubuntu, or any other things. So different flavors of real-time operating systems are VxWorks. This is commercial part, and FreeRTOS or real-time OS is the open source real-time operating system. So real-time operating system is a special type of OS designed for embedded systems, which is having a structure of hardware, okay, basic hardware BSP and RTOS kernel. Okay, next is application which is built in that OS. So most of the Bosch company or LG company or Haier company or Huawei company, all these companies are hardware building companies. Johnson and Johnson, escalators famous. All these are using VxWorks as the real-time operating system. So general purpose OS versus real-time operating system. General purpose OS, okay, the data is not timing critical, whereas in the real-time operating system, the data is real-time critical. What is real-time? The ability of operating system to provide required level of service in a bounded response time. So bounded response time is nothing but person ABC is traveling in a car, okay, and he hit to a tree. Immediately the airbags has to open. So this is bounded response time. So this is the ability of an operating system to operate on a required level amount of time. It has to not see the level of crash. Once the crash is reached the threshold value, it has to save the lives of the humans inside the car. So that is the real-time application. So RTOS is a real-time application which is built for embedded systems with bounded output. There are two types of RTOS, hard RTOS and soft RTOS. Hard RTOS is nothing but hard coded on the hardware, and soft RTOS are nothing but the which are applied on the software. So hard RTOS will come with air traffic control as an example, vehicle subsystem control, nuclear power plant control. So hard RTOS will operate only directly on the hardware part. So example, we have a flight, we have a button, we have to click the button, okay, so that to eject the wheels for landing. Then the button is clicked, the wheels has to open. If the wheels are not open, it is very critical. Okay, the failure will cause damage, whereas soft RTOS, the failure will not cause damage. The soft RTOS example are multimedia player in your car dashboard or your cellular network. If you fail, if you are speaking on a call and your call gets failed, you can reconnect your call. Computer games, those are also real-time operating system. If your game gets hang up, okay, once you reboot your device, you can restart your game also. So these are not critical, but whereas hard RTOS are very critical. So functions of RTOS are task management, scheduling, resource allocation, and interrupt handling. So task management is nothing but if we have any process, okay, we have to complete this task with a predefined amount of time in memory. Then it is called a task management. Then is nothing but scheduling. So task life cycle is like this. We are creating a task. Task is ready to execute and task is running. And when the task is running, it can go to suspended state or blocked state and the task can be deleted also. If it is a failure task. If it is a successful task, it will complete running. Okay. Else, if any hard interrupts or soft interrupts comes, it will go to suspended state or blocked state. This is the task life cycle. Next, scheduling in operating systems. So we have different models of scheduling. They are clock-driven scheduling. Based on the clock, the events has to trigger. Round-robin scheduling. If we have 4 tasks, all the 4 tasks are given equal amount of priority and equal amount of time to complete their jobs. And priority scheduling, whichever the task is having high priority, they are executed first, and the low priority tasks are executed in the last. So among all these, the most efficient one is priority scheduling and round robin scheduling. So in real-time operating systems, we'll use hybrid model of scheduling the tasks. Next is resource allocation and interrupt handling. Based on the resource allocation and interrupt handling, we will decide the operating system real time is meeting the functionality or not. Popular real time operating systems are VxWorks, LinksOS, RT Linux, Windows CE. These are all the popular real time operating systems which are used in our real life. Examples like aeroplane dashboard, car dashboard. Okay. Most of these are our real time examples. If you see some smart trucks, okay, smart trucks also has real time operating systems. So applications of real time operating systems are military, engineering applications, data communication systems, missiles, and advantages. So they are having a challenging and diverse environment condition. Very challenging environment conditions Artas has to work. And real-time operating consumes very less power and memory. Why? Because they are dedicated only for tasks management. And kernel size is very small. It's not completely like Red Hat Linux or Ubuntu Linux. And ROM storage for the embedded systems are also minimal. Okay. So this is all about real-time operating systems. And the next chapter of embedded systems and IoT is Raspberry Pi. Any questions so far? This completely recap and gist. If you have questions, I'll wait for 5 minutes. Please post your questions. Sanjay Bhavani Blackbucks team will answer these questions. If you have any questions related to the subject, please ask me related to real-time operating system, NodeMCU, or ESP8266, or Wi-Fi module, or C programming, or embedded microcontroller, Arduino, ESP, NodeMCU, 8 Mega 328, or ARM microcontroller, anything. Okay, not about assignments or internship classes. So the last 15 minutes, okay. So Blackbucks team will address your questions. Right, Kavya?
Yes, sir.
Thank you. If you have any questions related to the subject, presentation, slides, please post your questions. So coming to the next topic, Raspberry Pi. So I hope there are no questions related to the subject. I am proceeding further. Satya, Bhavani, so Blackbucks team will answer your questions in the last 15 minutes. So Raspberry Pi. So what is a Raspberry Pi? So Raspberry Pi is a very cheap microcontroller board which is built on ARM processor. Okay, so which is having Cortex series, M3 microcontroller series. So Raspberry Pi is a high level board which is having peripherals like USB, HDMI, Ethernet, and GPIO, all this. So it is like a mini computer. So this is embedded microcontroller board which is operating on Linux operating system. So the setup we have seen in detail how to install Raspberry Pi OS on Raspberry Pi board. So detailed explanation, the board architecture or the board description. Okay, on the rightmost part we have network, that is Ethernet LAN cable connection, and next is 4 ports USB for keyboard mouse connection. Next is 9mm jack for sound or audio, and there is a camera slit, and next is mini HDMI ports for connecting display monitors. Next is Type-C power cable. Next is below the board we have SD card. SD card can be supported from 16 GB, 32 GB, 64 GB, 128 GB, 256 GB, or even 1 TB also. So this kind of memory card we have to install with, or we have to boot with Raspberry Pi OS and insert it. Then the microcontroller board reads the SD card to boot the OS into Raspbian. Raspbian OS is a Linux based OS. The Raspberry Pi is a small computer, small footprint, 9 x 6 centimeters, 9 centimeters length and 6 centimeters breadth. Okay, once you connect the plug-in monitor, okay, you can connect general input purpose input output pins also for interfacing sensors, actuators, and other peripherals. So to learn Python programming or Raspberry Pi programming, we have to use Python programming language. As Raspberry Pi is a Linux operating system, you can use any kind of shell script to program the Raspberry Pi. So basically, we prefer Python. So microcontroller used on the Raspberry Pi is BCM Broadcom 2835. So we have pins like HDMI, GPIO, audio, USB, SD card, Ethernet, power supply. So the different versions of Raspberry Pi board are, first model is B in 2012 and A in 2013 and B plus in 2014 and A plus in 2014 and model B in 2015 and 0 Pi in 2015 and 0 Pi W in 2017 and 2019 B plus Raspberry Pi 3 model. Okay, so I'll give you the comparison how the journey has started of the Raspberry Pi, and A plus in 2019 and Cortex A series in 2020 model B, which is having the memory of 2 GB RAM and a clock frequency about 80 megahertz. No, not 80 megahertz, 2.3 gigahertz. So this is Raspberry Pi 400, which has inbuilt keyboard, Raspberry Pi GPIOs, and all those things, connectors. So the most famous Raspberry Pi board is this one, Raspberry Pi model 4. And 2024, we have a Raspberry Pi model 5. So Raspberry Pi model 5 has 4 GB RAM, and 2.5 gigahertz frequency. And Raspberry Pi model B 2020 has 2 GB of RAM. And this is also same Cortex A53 and A72. Cortex is nothing but is the ARM board, ARM processor of application series A72. This is the installation process for Raspberry Pi. So we have to install Raspberry Pi bootloader or installer in our desktop or laptop, Windows or in Linux. And we have to choose the device, which device we are using, Raspberry Pi 4, Raspberry Pi 3, Raspberry Pi 5, whichever the device is. We have to choose the operating system. Okay. So which operating system you want to install, recommendations will come. Okay. So based on that recommendations, we have to check the Raspberry Pi version, OS. Next is, which is your SD card. Once it detects the SD card, select that SD card and click for edit settings and apply your settings like host name, internet, SSH connection, enable and everything. Next, after that, go for save and go for yes to boot the OS on your SD card. Once your SD card is booted, you plug in that SD card on your Raspberry Pi board and boot it. You will be seeing the OS application. Once you see the OS application, you will be asking for authentication for username and password. Once you enter the username and password, you will be seeing a desktop application of Raspberry Pi OS similar like Windows or Ubuntu. Clear so far, everyone? Yes, sir. So for today, I am ending the session. Kavya, will it be fine? You can take up the next 15 minutes for
Yeah.
addressing their questions and
Okay,
their
sir.
doubts. Yeah. So
Yes, sir.
it's my time to leave the session. If you have any doubts related to the technical part, I'll wait for another 1 minute or 2 minutes to receive your questions. Please, students, candidates, if you have any questions related to the subject or microcontroller or any kind of board, if you need any support or help from my side on the subject part, please post your questions on the chat window. Else, I'll hand over the session to the Blackbucks team for your assignments doubts, for your generic doubts. Yeah, Kavya, take the session on your control. Okay. And stop sharing the screen. I'm leaving the session. If they have any subject related questions, please take them a note and revert it to me on my chat. Thank you.
Okay, sir.
Bye.
Before sending the attendance link, I'll just tell you how to submit your assignments and assessments. Please give me 1 second. Go to TapTap website, taptap.blackbucks.me. Uh, Here if you log in as a student with your email ID, you'll get this screen. Go to learn, tap on the courses, and in that, go to embedded systems and IoT. Here you can access your video lesson, and your assessment and assignment. Click on assessment. Here you'll get 20 MCQs. Start now. MCQs. If you want any video, here you can get your video lecture of session 1. This is assignment 1 is here. You can register and write your exam here. This is assessment 1, assignment 1. Like this, you can write your assessments and assignments. Go to tab.blackbucks.me login. Is there any questions regarding this? Okay. Okay, I'll again explain this. Go to Chrome and type tab.blackbucks.me login. Here you will get as a student, as a recruiter. Tap on as a student and choose your email. Give your email ID and you'll get this website. Go to learn. Here you'll get lesson plan and courses. Go to courses. Search for embedded systems and IoT. Tap on this. Here you can access your videos and assessments and assignments. After go through this video content, then write your assessments and assignments. Here you can write your assessment, description, register, daily test. Likewise, you can write your assessment and assignments. Is there any question? How many days left? This is last week of your videos. Today's class and Thursday's class is the recap, revision class. Sir will revise all the stuff told till now. One more class left, that's it. Thursday evening, 7:15, one more class is that. That's also revision class. That's only. File submission process. Go to assignment. There you can get your upload file, upload your file. You can upload your PPT or PDF, anything there. Yeah, you can get your certificate after completion of this assignment and assessment. And this Blackbucks will provide you some mini projects at the last 2 weeks or 1 week. Last date till the internship end, you can write your assessments and assignments. When provide. Deadline means internship end date. After evaluation of your assignment, the Blackbucks team will evaluate and give you a score. Zero means I think they didn't evaluated yours. How much percentage need? I guess 75%. I don't know exactly. After the internship, after the internship, how can you submit? Enrollment problem. co- Yeah, it's mandatory to complete employability test. Yeah, I'll post your attendance link just 2 minutes. Is there any doubt? Ask me in the chat box. I- If there are no doubts, I'll post. 15th July semester exams. I don't Okay. Actually, this week is the last week for videos. I mean classes and all. And next week you'll get you will assign your project. You have to do your project, mini project. Last date, I don't know exactly what's the last date of this internship. Tap done. Okay. I'm again explaining how to submit your assignments and assessments. Go to Chrome and search taptap.blackbucks.me slash login. Here you will get sign in as a student, as a recruiter. Tap on as a student. Choose your email ID and you will get like this. Go to learn courses, search for embedded systems and IoT. Here you will get your video content as well as assessments, assignments. So go through this video content and submit your assessments and assignments. Assessment is 20 MCQ questions. You have to answer them. And assignments is like you have to upload your PPT or PDF. There will be a question. You have to read it and you have to make or prepare your PPT or PDF and upload it there. And the Blackbucks team will evaluate your PPTs or PDFs and they'll assign your score. Is that clear? Zero score means you didn't did it well, or else they didn't evaluate it till now. Still, any more questions? You have to prepare your PPT or any PDF or Microsoft Word or Microsoft PPT on the required question. There will be a question, right? An assessment. They clearly mentioned what they expect from you, like block diagram, content. I mean, about the equipment and code explanation. So you have to mention all those stuff there, and you have to submit. Today topic, it's a revision class, right? It's all about till now classes con. 0 means either they didn't evaluate it till now, or else you didn't score well. About projects, they will assign you. Don't worry about projects. Still there is time, right? For 3 day, 4 5 days time. You don't bother about the mini projects, all those. Attendance. Don't bother about zero score. I think they didn't evaluate it till now. Wait for 2 more days and see. I don't know exactly the end date of this internship. And the last class is on Thursday at the same time. And after completion of these classes, you will go through your mini projects. And after completion of your project, only your internship will be completed. Course is not in lesson plan. Go to courses. In learn, go to courses and search for embedded systems and IoT. Not in lesson plan. Go to courses and search for embedded systems and IoT. There you will get your video content as well as assessments and assignments. Today's topic is a revision class, right? What I have to tell, recap session, yeah. It's a revision kind of thing. Where you are getting that message not enrolled kind thing. You have to do your assessments and assignments. Did you change your email ID or giving the same mail ID every time? Login with the same ID. Which files you will give, you want? Okay. Sign in with same mail ID every time. Not in lesson plan. Go tap on learn and go to courses. In courses, search for embedded systems and IoT. Not in lesson plan. I didn't mention lesson plan now. I told that go to learn and tap on courses and search for courses, embedded system and IoT course. Okay. Go to course and search for embedded systems and IoT, and there you will get your video content as well as assessments and assignments. No, it's not on lesson plans. Check in courses. What I have to repeat about the submission of assessments or what? Which website? Taptap.blackbug.me login. Taptap.blackbugs.me login. Still any questions can ask. About employability test, I'll answer in the next meet, definitely. I don't know why it's not changing. I'll definitely answer it. In the next class, I'll definitely answer. Okay, I'll answer it. You have to do your mini project at the at the end of your internship. Don't bother about the projects now. Yeah, you should do you on your own. On your own, you have to do your assignment. Sorry, assessment is a 20 MCQ questions. You have to answer. It's MCQs, 20 MCQs in the assessment. Assignments, you have to upload your PPT or PDF, Microsoft Word document, or a PowerPoint presentation. You have to prepare on your own and you have to submit it. Without submitting all those, you don't get the subject right. You have to learn something, right? When you are doing an internship, you have to learn something. So try to do your assessments and assignments. Then only you can learn your terminology or whatever, some small terms and wording. Without doing all the stuff, you can't, right? How can we provide? We can't provide certificate without doing all the stuff. So please try to do your assessments and assignments. You will get something. You will know some 2 3 points after doing those things. Minimum percentage about attendance or what? Assignment. Actually, I don't know the minimum percentage. Yeah, I think it's 50 or 40. I'll answer this question in the next meet. Minimum percentage of assessments and assignments. Minimum percentage to get certificate. This also I'll answer in next. Give your best and we'll see. I'll answer this in next meet. Minimum percentage to get certificate or minimum percentage to get in the assignments and assessments. Still any questions? Or else can I end this meet? Process for assignment submission. Okay. Go to Chrome and search backpack.blackbucks.me/login/ enter. It will give you this. Are you a student? Are you a recruiter? Tap on are you a student and sign in. Give the same mail ID when you are when you are login. After that, you will get this website. Go to learn. Tap on courses. Search for embedded systems and IoT. Tap on this. You'll get the video content as well as assessments and assignments here. You can go through the video content here, session 1. Here the video. Watch the video. After that, write your assessments. Assessments are 20 MCQs. Start now. It's MCQs. Here end date is 30 September 2024. Learn courses and search for embedded systems and IoT. Here assessments and here you will get assignment. Here is your assignment one. Like this, you can do. How many assessments? I think there are 9 or 10. Yeah, they'll assign you many projects. It's a teamwork, I think. Don't bother about projects now. It's in the end of the internship. Last part of the internship is doing your project. Okay? Laptop. You have to do in the Arduino IDE, right? I think it's necessary for projects. The teamwork. If it's a teamwork, it's one laptop is enough for one team. If it's an individual thing, you have to do it in the laptop. It's a requirement, mandatory thing. You have to upload your code, right? Code in the Arduino or Raspberry Pi. It's through the laptop only you can do this. Which documentation? PPTs or what? Yeah, it's in the website only. You can access your PPT summaries of the session, PPT, all those stuff. Okay, I'm closing the session. Thank you.